How does porosity affect the water table? Imagine digging into the ground and finding water just a few feet below the surface. What makes some places have water close to the surface while others stay dry? The answer often lies in something called porosity. Porosity is the amount of open space inside rocks or sediments where water can sit. Think of it like a sponge. Some sponges have lots of holes, and some have very few. The more holes, the more water they can hold. When rocks or sediments have high porosity, they can store a lot of water underground. This means the water table, which is the top level of saturated soil or rock, can be higher because there's more water stored beneath the surface. For example, sandy soils or gravel beds usually have high porosity. They can hold a lot of water, so the water table in these areas tends to be closer to the surface. On the other hand, materials with low porosity, like clay, have very few open spaces. They can hold some water, but not much. Because they can't store much water, the water table in these areas tends to be lower. Even if water seeps into the ground, it doesn't stay there long because it can't be held in large amounts. But porosity isn't the only factor that affects the water table. The ability of water to move through the material is called permeability. For example, clay has high porosity but low permeability. Water can sit in the tiny pores but can't flow through easily. This can cause water to get trapped and make the water table fluctuate differently compared to sandy areas where water moves freely. In groundwater systems, high porosity combined with good permeability helps water flow and recharge underground reservoirs quickly. This keeps the water table steady and reliable. Low permeability materials slow down water movement, so the water table can change more dramatically with rainfall or pumping. Knowing how porosity works helps us manage water resources better. It helps predict how the water table will respond to rain, drought, or human activities. For example, in areas with high porosity and permeability, wells can produce more water easily. But in low porosity zones, contaminants can stay trapped longer because water moves slowly, making cleanup more challenging. So, porosity plays a big role in how much water the ground can hold and how high the water table can rise. It also influences how water moves underground, affecting everything from drinking water supplies to environmental health. Understanding this relationship helps us better care for our groundwater and plan for future water needs.